Yeah, comes on everyone. Let's start off. Great. So last thing we are doing is Poiseuille's equation. Hope everyone has resolved these questions. Told you quite important. Great. Next thing, Stokes law. So what is the Stokes law? The viscous force on a spherical body is proportional to the radius and relative velocity of body with respect to fluid. Others comes on. So what the meaning of this is, let's say if you have a sphere going with speed v, and let's say the surrounding liquid itself is going with speed u, then the viscous force acting on this system is given by minus indicates a position, minus r eta v relative. Remember, v is not the velocity of the ball, v is the relative velocity. So here the negative indicates opposition. So in this scenario, v relative is v minus u. Example, now this is completely an experimental quantity. There is no theoretical proof for this. Neil, Ishan, Kamson, Ankita, Kamson. Now, first thing you need to understand, this, whatever we proved here, is only valid for a spherical body. This is not valid for, any kind of shape. It's only valid for a spherical body here. So the meaning of this, let's say this guy is going with V, right? And the fluid is flowing with U. Example, let's say the fluid is flowing with 3U. And let's say this guy is going with U. What is the direction of the friction? What is the direction of viscous force? You need to understand, friction does not oppose motion. It opposes relative motion. Think of like this. Imagine you're in a station, right? Local railway station, and you're getting down and there's a huge crowd. If you walk slower than the crowd, what will the crowd do to you? They're going to push you forward, isn't it? If you walk faster than the crowd is going to push you back. So here, if you see V relative, in this case, the friction F viscous will be in the forward direction. Because here V relative is negative. Here V relative is U minus 3U. So understand, friction is not opposite to velocity. It is actually opposite to relative velocity. Same thing, if this is U, and let's say the liquid is also flowing with you, then what happens? V relative is 0. There is no viscous force. Clear? So this 6 pi r eta v, v is not the velocity of the ball, v is the relative velocity of the ball. That's it. This is the one straightforward formula there for Stokes law. But the only problem, this is valid for spherical bodies. You can't apply this for any other weird shape. So whenever a body flows through a fluid, this is the scenario. There is an external frictional viscous force. Clear? You can just put down that. Don't worry about writing the notes. You will get the PDF, so focus on that. You can just put the thing in the red box. Clear? Let's see a question. That's it. Concept-wise, there's nothing more on Stokes' law. So we have a liquid here, the rho liquid. Eta is the quotient of viscosity. And in this, you released a ball from rest. Rho b is the density. A sphere is released from rest. And density of the body is greater than density of liquid. So it sinks. Gravity is there. And this is a pretty deep liquid, so there is no depth as such. And the radius is r. First thing, find velocity as function of time t. Find the velocity of ball at time t. Second, plot VT graph, AT graph, and XT graph. We have done something like this in the last session. C, find the heat produced per second. Heat produced per second is proportional to R power n. This is after a long time, okay? Find n. Find V terminal. V terminal is the velocity at infinity. Let's get this. The previous page, have a look at this. Got an answer? Please type in the chat box here. I know the answers might be a little weird to type, but yeah. Clear? Hmm. So a sphere is released from rest, it starts sinking. Find the velocity as function of time t. Start with that. I'll just tell you the starting part. How many forces are there? Mg, bind force, and viscous force. Once you write the equation, it becomes just a max question. Try. I'll give you a minute more. You got the velocity, go for the second part. Plot the graphs. VT graph, AT graph, and XT graph. So mg minus F viscous, F buoyant force is mass into acceleration. This is rho body. It's a sphere, so 4 by 3 pi r cube g. Viscous force is 6 pi r eta v. Buoyant force is rho liquid, 4 by 3 pi r cube g. Mass into acceleration is rho body, 4 by 3 pi r cube into a. Hope you got the equation right. Once you got this, this would be rho b minus rho l. Bring that 4 pi r cube here. G minus 6 pi r eta v by 4 by 3 pi r cube is equal to rho b into a is dv by dt. So this will be dv rho b by rho b minus rho lg. This guy would be 9 by 2. Pi will cancel. R square eta v. 3 2 will cancel. Yeah. 9 by 2 r square eta v. This is dt. Making sense? I just simplified it. So this, what we will do, right? You can bring that rho b also down if you want. This is rho b and 9 eta v by rho b r square. So this, let's write this as dv is equal to p minus qv, where p is equal to that one, rho b minus rho lg by rho b. And this q is another constant, which is 9 eta to rho b r square. Now, it looks easy to integrate. 0 to velocity, 0 to time. This guy will be minus 1 by q ln p minus qv. Limits will go from 0 to v is equal to t. This would be ln p minus qv by p. I substituted the values and subtracted them is equal to minus qt. So from here we end up with p is equal to p by q into 1 minus e power minus qt. Check. That's your velocity as function of time t, where p is this and q is this, which are constants anyways. Clear the steps. It looks complex, so don't get scared of the variables. See how much actually integrate to do. Finally, integration is simply p minus q integration. Clear? Now, here, which we get this thing, if you want terminal velocity, what is terminal velocity? Meaning the velocity has become constant. Or you can say at terminal velocity, v becomes constant. Therefore, acceleration is 0. So this itself is a direct mains question. Huh? Yeah, it's an exponential decreasing function. So a is 0. So you can actually directly get the answer from here. So mg minus fv minus fp is equal to 0. So this guy would be 6 pi r eta v terminal should be equal to fb, that is mg, no? So rho body minus rho liquid 4 by 3 pi r cube g. So you end up with v terminal is equal to 2 by 9 r square g rho b minus rho l by eta. Yeah, definitely mug up this thing. Huh? Standard result, mains and bits, direct question. We can put T infinity also, but if you just want V terminal velocity, why you want to integrate all this? Isn't it waste of time? If you just want terminal velocity, just put equal to 0, na, you get the answer from here only. Exam mein, where will you do this much in a mains level question? It's a waste of time. Please have a look at the steps. Yeah, if you put T infinity, you should get the same though. That means eventually, right, the velocity will tend to a constant value. This is your terminal velocity. And you can clearly see V terminal is proportional to R square. The meaning of this is if you have a ball of radius R and if you have a ball of radius 2R, if this guy goes with V, this guy goes with 4V. Assuming everything else is same. Any doubts on this page? Like I said, the moment you have written this equation, physics is done. It just becomes a max question after this. This one is an easy part. Now, how to draw the graphs? Let's draw the VT graph. So VT graph, we got an exponential graph. So velocity versus time graph, you start from 0. As you go, you keep tending to a constant value. This is your V terminal. You're getting closer and closer, but you'll never reach that. How does an AT graph look like? Initially, you start with an acceleration g because initially there's no velocity. Eventually, you'll tend towards 0. It is an exponentially decreasing function. So this is always decreasing, but never becomes 0 actually. It takes infinite time. This is always increasing, but never actually reaches VT. They can ask a question like this in statements. The body, the velocity is always increasing. True. It reaches constant at infinity. It doesn't exist. What about XT graph? Out of all, XT graph is a cool one. If you remember, last time I told you about the Planck. In XT graph, you start from this, and then you start tending towards a line. If you draw a line here, theta, tan theta should be V terminal. Remember, in XT graph, the slope is velocity. The slope in XT graph is velocity. That means eventually the slope of an XT graph should get closer and closer to this line. It is becoming a straight line. But again, it will never touch the line. That's how an XT graph looks. It tends towards that line, but it will never touch that line. Eventually, it becomes a line. Yeah, have a look at this page. Any doubts on this page? If you just want to find V terminal, no need to integrate. You just put A is equal to 0 and you would get the answer. Like I said, viscosity is a small topic. We'll be wrapping up today. This thing will start with surface tension. Clear with this? Can I go ahead?
Yes, sir.
This page is also clear?
Yes, sir.
Great. This is also clear. Now, there's one thing I asked you. Heat produced per second. Now, heat produced per second is nothing but power due to viscous force. The only dissipating force here is viscous force, which is nothing but F viscous into velocity. So this is 6 pi r eta v terminal into v terminal. So this would be 6 pi r eta v terminal square. So this is proportional to r into v terminal square. But we also know v terminal is proportional to r square. This would be r power 5. It's a pretty rare formula again, a power 5. So heat produced per second is proportional to r power 5. This question, I was teaching somewhere in 2018 May to a medical batch. It came in that year ke exam. Right? The student calls up and says, "Sir, remember that formulas you gave in the notes, they came directly." I said, "Good, good. Did you do?" "No, sir, I forgot." I said, "Then why the hell did you call and tell me like you got it?" Matlab, like, he's excited, "Sir, आपका note से questions आया." I said, "That is great. But did you answer it?" "नहीं, sir, उस time याद नहीं था." I said, "यार." Then I tell them, it is not like, I predict the questions or something. Point kya hai na, by the time we finish off our notes, we'll be having around 1200, 1300 questions all over. And when you do so many, something or the other will bound to happen. Clear with this? So the heat produces r power 5. Velocity is proportional to r square. Please check it out. Now I have a doubt in this actually. Let me ask you that. But first, let's be clear with the graphs. People, today night is a deadline for the exam, huh? Today, Wednesday night. Sorry. Tomorrow night is a deadline. I know. I scared you guys. I forgot. Tomorrow's a deadline. Don't skip the test, right? Getting it? See, that's what I'm saying. Don't worry about the scores. You mess up the test, at least you got a chance to learn whatever it didn't go through. So don't think like, array, score. Every exam is not to score. Now, the doubt here I have is, listen, this is a good one. This is a good theoretical question they can ask you. Now, when the body has reached terminal velocity, this is after a long time. So body is moving with terminal velocity. So at any point of time, if you observe the body here, the forces acting on this are mg, F viscous, and F buoyant force. Great. So here, mg is losing energy. Fair enough. Heat produced per second. The viscous force is producing heat. Is power due to viscous force. Fair enough. So my question is, what the hell is the buoyant force doing? What is power due to buoyant force? Where is this going? Meaning, example, I tell you, see, let's say in 1 second, in 1 meter, let's say this thing falls 1 meter height. So how much potential energy did you lose? mg1. In this, some part of the energy became heat. That is done by viscous force. So remember, only viscous force is a dissipative force. It's like friction. It produces heat. Fair enough. But the some part of it is buoyant force. What is this buoyant force doing with that energy? So whatever potential energy you're losing, it is being consumed by viscous force and buoyant force. Gods, these are energies, not balancing off. You're talking about force. Let me ask you one thing. Maybe fundamentally, right? Can you tell me what is the difference between force and energy? What's the difference between force and energy? Again, there is no proper definition as such, but technically you can give some example or something. What do you think is the difference? Capacity to do work is energy. That is so layman's definition. Force is applied, but energy is really nah, that's not the word I'm looking for. That doesn't mean much. In a more layman terms, this is what I'll tell you. See, we discussed in work per energy also. Energy is like a quantity, maybe like money or something. Force is a force converts energy from one form to another form. Think about this. Whenever energy changes from one form to another form, there is always a force involved. Whenever a body is falling from a height, the mg force converts the gravitational potential energy into kinetic energy, isn't it? The force is like, let's say I have rupees and I want to convert into dollars. So energy is money. It is becoming rupees to dollars. The person in the cashier in the bank who converts this money, the exchange person, is the force. I hope you're getting the analogy there. Force is not energy. Force is a person who converts energy from one form to another form. Are you getting the catch? Whereas energy is like money in dollars, rupees, yen, ruble, different currencies. Is a different forms of energy. Getting it? Think about it. You think of any other force, right? When you have a spring and a block is moving with velocity, the spring force converts the kinetic energy into spring energy, isn't it? Whenever energy changes form from one form to another form, there is always a force involved. I hope that is making sense. So that we have a clarity. What is force? What is energy? Both are not same. Energy is a cause of force. No, it is like, see, energy is always there. It is like always have the money. When I wanted to change to another form, I need a person to exchange that money. So force is involved to exchange this thing. So my question is, I hope you got the point. My question is, mg is losing energy. I know mg is fv plus fp. That means whatever energy is lost due to gravitation, some part is taken by viscous force, some part is taken by buoyant force. So buoyant force is taking some energy. Where is this energy going? It's a pretty good question. So I'll show you 2, 3 pretty good questions you can ask on theoretical questions. Think I'll give 30, 40 seconds. I hope everyone understood the question. Whenever the ball falls, it loses gravitational potential energy that is being converted into heat plus something else. Heat, though, we wrote it around the 6 pi, free viscous force and all, but the buoyant force is doing something. We have to find power and do what? No, I'm not asking find power and all. I'm asking, sure, you want to find power? I'll calculate for you. That is F buoyant force into V terminal. So my question is, what is happening to the power? Where is this going? If I ask you where is this going, what will you say? It is becoming heat. This is FV into V terminal. This is becoming heat. So whatever work the viscous force is doing, it is making heat. Where is this going? Slowing the ball. It used to create ripples in the liquid. Wow. What? And I like you guys, right? What else? I guess it's still fine. If I ask something like this to medical people, though, they talk something else only. It's like I was asking them recently, like, when a person falls into a river, lake, right, he sinks. But after he dies, the dead body floats. Getting it? This is what I asked. I said, like, what do you think? Medical batch. And someone says, sir, Atma jab upar chala jata hai, right? The weight decreases and the body floats. I said, boss, awesome. मतलब you guys are going to become doctors. सब लोग शुद्ध तांत्रिक ऐसा कुछ मुझे इसके लेकर देख के अगोरा टाइप लग रहा था सब लोग. ऐसा ही ट्रीट करो पेशेंट को. आत्मा ऊपर जाएगा, आत्मा डांस कर रहा है यार. नहीं, shape doesn't change रहा होता. It's a rigid word. Used to convert Ke to Pe. अरे God, that is velocity is constant ना. Are you getting terminal velocity reach हो गया? Kinetic energy is not increasing. Aryan, velocity is constant. Kinetic energy is not increasing. Let me tell you where it is going. Should I tell you?
You're asking at steady state about it.
Steady state, after a long time, body has reached terminal velocity.
So it's okay, tell, I don't think.
Ronak, you are little close by, but see, Bayern force is actually doing something. What it is doing, initially when the ball is here, okay, now when the ball goes from here to here, what happens? So when the ball comes from here to here, the ball goes here. But this liquid which was there, this liquid from here has gone up. The displaced liquid goes up. Next moment, when the ball continues to go downward, this liquid goes up. The liquid is continuously going up. On the surface level, you don't realize it. So if I just draw the liquid, you will see. If I just draw FBDs of the liquid, this is what you'll observe. See, liquid only. Initially, the cavity is here. After some time, the cavity is here. If you just remove the ball and draw the liquid, after some time, the cavity is here. What is happening to the centromass of the liquid? If you take this as the centromass of liquid, it has gone up here. It has gone up here. What is happening to the centromass? Centromass of the liquid is going up. The surface level, the thing will look same. Liquid goes up. So this Bayern force, what it is doing, this is used to increase the potential energy of the liquid. Potential energy of the surrounding liquid. The height of the liquid won't change, but internally the liquid is going up continuously. Is that making sense? So now in the exam, I will ask you this question. When a body is dropped into the liquid, what happens to potential energy of the system? Increase or decrease? What happens to the potential energy of the system? Decreases. Because the ball is also sinking now. If I ask you only potential energy of the liquid, then increases. So when I say system here, it is ball plus liquid. Remember, ball is more denser than liquid. So a heavier ball is sinking. So the center mass of the whole system is going down. So center mass of the liquid goes up. Center mass of ball plus liquid goes down. These questions will be statement questions in the exam. Clear with this? I think simply I'll ask a question like this and people won't understand. Huh? I will say there's a container, there's a liquid, there's a ball here, ball is sinking. Ball is heavier, rho b is greater than rho l. The statement questions or matrix matching questions will be potential energy of the liquid is increasing, potential energy of the liquid is decreasing. Everyone will think, yeah, height is not changing. Why will potential energy change? What was happening is internally the central mass is going up. Is this making sense, everyone? So when the ball falls down, the gravitational potential energy is converted into two things. One becomes heat, one becomes potential energy of the liquid. Is the explanation making sense, everyone? So they can ask you multiple questions on this. When a ball is sinking, what happens to potential energy of the liquid? How does the central mass of the liquid move? How does the central mass of the system move? So I can ask you different things in terms of central mass and potential energy. Please check out this page. The height of the liquid will be same. Clear, na? Ronak, got this thing? Yasha? Utsa, understood? Utsa there? You got stuck, I guess. Vidyut, clear. Let's see one more. Any doubts on this? Pretty good question. It has multiple things on this. This itself is a direct mains and bits level question. Getting it? This is a velocity as function of time t. Graphs are good. The heat proportional to r power 5. In physics, can you tell me till now how many times you saw r power 5? You saw once before. The power 4 तो देखा था, power 5 भी देखा था हमने एक बार. Where? Heat transfer में. हाँ, radiation में. The lambda m into t means displacement law graph का the peak value is power 5. Remember that? That was t power 5. Clear. Next one. Turn in the page. Let's do an easy one. So we have a ball here, 3 row and radius r. We have a ball here, 2 row and radius 2r. The density of the liquid is rho. Viscosity is zeta. Find the ratio of terminal velocity. Straightforward, a mains level question. Find ratio of terminal velocities. Now don't blindly say the formula V is proportional to r square. That formula is valid when the densities were same. Here body cut densities are also different. Remembering formulas is good, but you need to understand when to use, when not to use. Finish off, easy one, direct formula substitution. I'll just write down here, this guy is V now. So the heat is H. This will produce heat 32 H. Keep that in mind. That's a simple question. Mains mein they do ask such things. Out of 25 questions, if the paper comes really like last 4 years, aram se you guys should be able to score 95. You can go one question wrong. That is the level of the paper. Unfortunately, every year, the topper of physics is mostly a medical student only. This year I still got 100 out of 100 for physics, but medical people did score 95 because they don't solve max now. They sit there and 1.5 hour aram se they do physics. And second thing, JE students see the max paper and get scared and panicky. What is the terminal velocity? The first one, let's call it V1, which is 2 by 9 r square g 3 rho minus rho by eta. V2 will be 2 by 9 2r whole square g by eta 2 rho minus rho. Divide them. So V1 by V2 will be 1 by 4 and that will be 2 is to 1. So 1 is to 2. Clear? Easy? That's straightforward. Next one. So you should know the formula. Be careful, it's not always proportional to r square. The densities also have to be same. Turn in the page. Any doubts, please ask. Perfect. So we have a ball here, density 2 rho, radius r. This is connected to another ball here. Density is 2 rho and radius 2r. So this is placed in a liquid. This is density of liquid is rho and viscosity is theta. The system is released from rest. This is tension T. This is a string. Find the terminal velocity and tension in the string after a long time. Find V terminal and tension in the string after a long time. Both of them have same density too. One is R and one is 2R. Two D R square 3 N. Okay. Find the tension also. Easy one. If you just draw the FBDs, you'll get it. Eight by 27. That looks wrong. 2R square G by 3. I think we have two answers with the same thing. You can type your answers to the chat box here. So we have 2 by 3 R square rho G by 3 theta. Might be right. Try. Another 30 seconds, I'll show you. Just draw the FBD of the whole system together. Since you reach terminal velocity, acceleration of the system is 0. So there are two weights, two buoyant forces, and two viscous forces. Total 6 forces are there. Tension is internal. So the two weights should balance two buoyant forces and two viscous forces. We have 8, that is P or pi. 8 by 3.
First one is rho, then it is pi. This tension.
And this also looks wrong. Let's see. The first one, I don't know. I don't remember the answer. Let me solve. Anyone else got something? Check your FBD, see whether you got the same equations. Anika, that is definitely wrong. Your dimension is not matching. That is one more important skill. Huh? It's okay if you don't know what's the right answer, but the moment you see the answer, you should know it's a blunder. The problem we think, we think our subject is good, so we should score. Just because your subject is good doesn't mean you'll do the exam well. So what is this guy? This is 2 rho. Let me 2 rho 4 by 3 pi 2r whole cube g rho vg. The bind force. This is your mg. Let's call this thing FB1. Let's call it FB2. Let's call this thing M2G. FB2 will be density of the liquid 4 by 3 pi 2r whole cube G. This is the viscous force. Let's call it FV2. 6 pi r is 2r eta V. Let me write that statement. So after a long time, acceleration of the system is 0. This is tension. This is tension. You can ignore that. Then you have your own weight here, m1g, which is rho 4 by 3, sorry, 2 rho 4 by 3 pi r cube g. Viscous force Fe1, someone got 28 by 3. Okay, let's see. 6 pi r eta v. The bind force Fp1 is rho 4 by 3 pi r cube g. That's it. It just looks big, but if you got this, your job's done. Now there's a, how do I simplify? See, take this guy and this guy. Your life becomes easy. See, that is 2 rho minus rho. Take this guy and this guy. That becomes easy. That is 2 rho minus rho. So I can simplify this thing as, so 2 rho minus rho, that becomes rho 4 by 3 pi r cube g into 8. So I took these two guys. Then I took these two guys. Plus, that would be 2 rho minus rho is rho 4 by 3 pi r cube g. Minus, I wrote that I'm taking these two guys. That would be 6 pi r eta v plus 12 pi r eta v is equal to 0. How much is this? This is 8 plus 1. That becomes 9. There is a 3 there. That is 3. So 12 rho 4 pi r cube g. That becomes 18 pi r eta v. So v is equal to, that is 6 2 by 3. 2 by 3 looks right? Most of you guys got it. 2 by 3 r square g by theta. Yeah, right, Ishan. You got it. You guys got it. Who else got this? Anusha, you also got it. Suchir, you got it. Aryan, you got it. Others, check. See where it went wrong. Where did you mess up the equations? After that, it's just a matter of adding it up. I hope I didn't mess up any calculations though. Clear? How to find tension? Take FBD of any one ball. If you take FBD of the small ball, you get tension plus M1G minus FB1 minus FB1 is 0. So tension is M1G FB1 plus FB1 minus M1G. Substitute the values, you'll get the answer. I will leave it to you. You know all the values now. Substitute and you'll get the answer. That is easy. Okay, that's coming out how much? 8 pi r. Okay? 8 by 3 rho r cube. I don't know. People are saying, I'm writing it down. You didn't get a pi kya? Pi bhi hona chahiye.
I and G.
Okay. Is that the answer? Anyone got it?
Yes.
Okay. You can substitute and check it out. It's fine. It's not a big deal. Easy? Any doubts on this thing? Right, Anusha. I think it looks right. Clear, na, Aditya? Abhinav? Got this? Now, don't see the things and get scared. Na? It looks big, but actually, if you see, technically, we are just drawing FBDs. We are doing an equilibrium problem. 2 viscous force, 2 buoyant force, and 2 mgs. So this is an easy question, which is little lengthy. So don't get confused between a lengthy question and a tough question. Next one. Tough question is something which doesn't strike only what to do. Lengthy questions are fine. Most of the questions in advanced physics, right, are lengthy questions. So we have a tall building here, H. There is an air resistance. So let's say air resistance F is given by F is equal to minus kV. K is some constant. So F is the viscous force opposite to velocity. V bar is the velocity of the ball. Gravity is also there. So someone took a ball here and projected horizontally with speed u. So this thing starts going up. I want a projectile motion because now there is an air resistance. Find the x and y coordinate as function of time t. So you can start this point as origin. Projectile motion with air resistance. If h tends to infinity, find the range. Range is the maximum horizontal distance. Or I can say if h tends to infinity, draw the trajectory. That is a better one. From there we can find everything. If you want a simple version of this question, I would have asked like this. I would say time of flight is t, find range. That would be a simpler version of the question. But okay, this is even better. There, I know when we started kinematics, we said there's no air resistance and all. You always wanted some air resistance. You guys didn't feel it was real. So there. When we get back to reality, we have to use calculus. How the question is clear. Again, don't jump into the solving part. First, figure out how will the forces look. And how do we always solve? After some time t. After time t, the ball is here. It looks like this. So forces will look like this. Take a minute always to analyze the problem. The moment you see a question doesn't mean you should put your pen on the paper. Most people, when they see the question, they formulate the whole plan. Question they okay, इसमें ऐसा हो रहा है, ऐसा हो रहा है, ऐसा करना है, and then you start off. Try. I'll give you 2 minutes. Take a minute, then I'll show you the FBD. Then I'll give you a minute more. Let's see after a minute, did you get the FBD and the equations right? See your FBD. So at any instant, let the velocities be, this is V bar. Let the velocity V bar be Vx I cap plus Vy j cap. So the viscous force is supposed to be this way. Mg is this way. So to make your life easy, we can write the components. This guy will be Kvx. This guy will be Kvy. Agreed? The horizontal component of viscous force and the vertical component of viscous force. I hope you guys have not used the three equations, huh? You can't use the three equations. God's A is not constant. That is how the FPD looks. So this body actually has two accelerations. There is a vertical acceleration AY and there's a horizontal acceleration AX. The F viscous is minus kV bar, no? So minus kV xi cap. So there's a horizontal component of frictional force and there's a vertical component of frictional force. Nay, records, you'll get exponential functions. So just to help you with the equation, so vertical direction we'll write. In vertical direction, the equation should be mg minus kby is equal to may. In the horizontal direction, there's only one thing there, kvx is equal to max. Those are your equations. Now what to do? Try. I'll give another minute. Anyone not clear with the question, please ask. If you didn't understand the question, it is always my fault. You don't know how to do, that is fine. Try for 3-4 minutes. I'm there anyway to show you. Clear with the question? Can I go ahead? And it looks like kind of max class. Let's get this thing. But these all are like pretty basic integrations when they actually learn in max. X is e power. Sir, remember I told you something? You'll never get e power plus in life.
Sorry. So that minus.
माइनस आना चाहिए. वो क्या है ना, velocity decrease हो रहा है ना, so ax will be minus dv by x by dt. So out of all ना, x is the easiest one to integrate. Ax, this is minus m dvx by dt, minus n because v is decreasing. Adrit. That looks weird, Ray. Your dimensions are not matching. So Chana, what you wrote g minus k into e power something. The dimensions are not matching. So this thing integrate. dvx by vx is equal to minus k by m dt. Integrate on both sides. Initial velocity is u, final velocity is vx. This will go from 0 to t. That will ln vx by u is equal to minus kt by m. This gives you vx is equal to u into e power minus kt by m, but that's not what I asked you. What is vx? Dx by dt. U into e power minus kt by m. Integrate again. I'll do one thing. I'll do that on the next page. What about this guy? Here I won't write a minus n because the speed is increasing. This is mg. So this guy would be minus 1 by k ln mg minus k vy. Limits will go from 0 to vy, and this is dt. I hope everyone is getting that integration. In case you forgot, let me write it down for you. Dx by ax plus b integral is 1 by a ln ax plus b. This much to remember, very common in physics. This much integration you should know. Dx by ax plus b, where a and b are constants, is 1 by a ln ax plus b. This guy would be I'm skipping a lot of steps, huh? Check. That's your Vy and Vx as function of time t. Please check the steps. Clear? Then integrate again.
So the exponent e can
Hmm.
be answer
Come again.
would be minus k t by. I mean, I'm
Minus kt by m क्या? I wrote reverse. You're right. I goofed up there. Please check. Zero to t, zero to t. So y coordinate would be this would be t. That minus would come off. That would be m by k e power ax now 1 by e power ax, that is e power minus kt by m. Limits will go from 0 to t. Be careful, e power 0 is not 0. E power t minus e power 0. That's your y coordinate function of time d. Hi, Ishan, right, I goofed up. What is Vx? Same thing. Vx is easy. But in the exam, right, they could ask you find the trajectory. That would be more interesting. इतना effort नहीं लगेगा, but that's more interesting. 0 to x and 0 to t. This guy would be x is equal to mu by k. Check. That's your x coordinate. You know how will the trajectory look like? If the building is very tall, when you project this, look at this thing. At t tends to infinity, x ka value will tend to mu by k. Means you cannot exceed this x coordinate. So this guy is becoming straighter and straighter and straighter. It's a very tall building where this value is mu by k. So there is kind of like a limit here. You cannot cross that x coordinate. This guy is becoming straight, 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 and eventually the velocity becomes at infinity.
फिर y के जो अपने लिमिट्स डाले वो 0 से नहीं होंगे ना?
I'm starting from origin only, na, meaning
अच्छा, you took that origin. Okay, fine.
मैं क्या ले लेना? I took this as y and this is x axis. तो simplicity और कुछ नहीं है. I could that will be minus y लेना पड़ेगा और कुछ नहीं है. So horizontally it cannot exceed this value mu by k. You cannot exceed this value mu by k. That is the maximum range you can get. And at t infinity, vx will become 0 and vy will become, if I put t0, t infinity here, this will become mg by k. So at infinity, the body is going down. It becomes vertical. Huh? There is no horizontal component. The velocity of the body is mg by k. You're getting? It is getting closer and closer to that blue line, but it will never touch that line. That is how the trajectory looks. It's not a parabola. So particle never crosses this x coordinate. This is the maximum x coordinate. So exam they'll ask you like this: if the height of the building is infinity, if h tends to infinity, what is the maximum x coordinate? Clear with this? I hope everyone got the steps. There, with that, we're done with viscosity. The second part, surface tension. Any doubts on this problem, please ask me. Surface tension is again another, it's a little weird one, meaning it's not tough. The problem is what I saw, right? People have difficulty visualizing. That is the main thing, or else the chapters is quite easy. Let's see, don't worry. I will try to do my best to explain you in detail what the hell it is. Like I keep saying, if you actually understand what it is, it becomes easy to figure it out. So, surface tension. So let's start off like this. So, first we need to go to the fundamental level. If you talk about this thing in molecules, or let's say in fluids, each molecule interacts with surrounding molecules up to a distance of 15 molecular diameters. Again, this is kind of an approximation. It does interact with everything. We call this thing sphere of influence. In chemistry, we call this thing van der Waals forces. This interaction is what we call as van der Waals forces. That means if I have a molecule here, if you draw a circle whose radius is 15 molecular diameters, means it basically interacts with everyone, 15 molecules in every direction. Not just an approximate number. Just for our reference, somewhere you have to define a line. So they defined 15. Now, because of this, this is called sphere of influence. Now, when you take a liquid, you'll notice something. So in a liquid, there are three different force profiles. In a liquid, molecules have three different or three force profiles. Basically, FBT, force profile, looks more professional. So what is this? First one, the molecule inside the liquid, if you observe, this is being attracted by every molecule in all the directions. Getting it? So on this, the F net is 0. So the first one, molecules inside the liquid have net force 0. The molecules on the surface will have attraction only due to the molecules inside. So there is a net downward force. Did you see the force is different for these molecules? The molecules on the inside and the molecules on the surface don't behave the same way. The molecules on the corner, they're actually more weird. On one side, you have the liquid, and on another side, you have the solid. These are the adhesive forces. There's a force between the solid and liquid. So these are three different force profiles. So in the liquid, you'll find molecules with three different types of forces on them. So molecules on the surface have net downward force. This is what we're interested in. This is what causes surface tension. We will see how. The molecules on the corner, that's what creates, capillary action. You will see later on contact angle and all that stuff. The liquid starts rising up. Interact with both solid and liquid. Is this thing clear, everyone? So this is the first thing you should know. How will the molecules will be? So in the liquid, there are three different force profiles. There are molecules inside, there are molecules on the surface, there are molecules on the corner. Clear? Now, let's see what happens with the molecules on the top. Because there's a net downward force, everyone is trying to be pushed inside. But the net volume is constant, meaning if you go inside, someone has to come outside. Getting it? So even though there is a force, you can't go inside because there is a thing. So because of this net downward force, the surface actually becomes more packed. So if you look at the surface molecules, they're more orderly packed. And because of the net downward force. Whereas the molecules inside are random. Because net force is 0, they can be in any direction they want. The net downward force makes them more orderly packed. Basically, this is an unbalanced forces. Due to this, molecules on the surface are orderly packed. Make sense? Yeah, we are neglecting air molecules. Generally, they're pretty less, so we can ignore that. Now, whereas the molecules inside, right, they're randomly moving because the net force is zero. So think of like this, huh? Let's say ever been to a some rock show or auditorium, anything there. If you see, if you're going from the back of the line, you can push through each person, you can go off, right? No one will resist. But if you try to go from the front through the line, what will happen? They'll push you back, isn't it? Because it's more tightly packed. Think of like this. So the molecules are doing something like this. The molecules are like people who are holding their hands. Now, this is what has happened actually, literally. Now, if you try to run straight and bulldoze through them, what will happen? I will draw a little stretched hand, so their hands will become like this. My hands don't stretch, but take something like this. And you will be like this. So they will not let you go. So this hand is pushing you this way, and this hand is pushing you this way. So the net force is upward. They'll push you out. You getting it? So because of this orderly packing on the surface, right, the entire surface will start resisting anything that is coming towards the surface. It starts acting like a membrane. Now, because of this phenomena, because of the tightly orderly packed, the surface of the liquid behaves like a stretched membrane. This phenomena is called surface tension. So just think of like that. Because all the molecules are tightly packed, they will resist any deformation or any change. So how does this look? We started classes for junior, I gave them a homework. They all are struggling. Remember that cone wala problem? Why are you not opening? Something happened to this. See, this is like a mosquito or something sitting on the water. Can you see how the surface is bending here? This is more clear. So you must have seen, right? This BMC people spray that kerosene and everything on the water. What they're trying to do is when you spray kerosene on this thing, the surface tension, right, it decreases. So when a mosquito comes and lands on the water, it sinks. So you're actually killing mosquitoes by drowning them. And we think, these BMC people are using some superior, expensive chemicals to kill the mosquitoes. You're simply drowning them. So this is what I was saying. because of that orderly packing on the surface, right? The molecules on the surface will look like stretched membrane. So mosquito can stand on this thing. So can humans sit on the water? On water, it is difficult, but if you can change the fluid into something, then it is possible. Let's see how that looks. Where are you? You can clearly see the surface. Did you see when the girl is walking how the surface is bending? What they did here, they actually took cornstarch. They make a bhajia. They took that cornstarch, they took it in 2:1 ratio, 2 parts of cornstarch and 1 part of water. They mixed it and they kept it, so it has become quite viscous.
So this is like a tub of it, and they are walking on.
Huh. That's a cornstarch and water. There, that's how it looks. So you can make bhaji out of it, but we are dancing on it. There, you can just jump on it. The thing is, the moment you stop, you will sink. Here you can clearly see the surface bending. Huh? Literally it bends, just like a trampoline, if you think about it. If you stop, this is what will happen. This guy is having fun. There. You can clearly see this is playing football. So there, humans can do that. Let me show you one. I'll show you something which can walk on water. Where are you? This guy.
Some young Costa Rican basilisk lizards are looking for food.
That's a lizard.
Basilisks have been nicknamed the Jesus Christ lizard. Why?
Lizard ka name is Jesus Christ lizard. Okay. So that is the actual name of the lizard.
This adult male, probably the father of the young lizards, can't tell us. Nor can this female.
Let's go to the story actually. So there is a lizard. Now there is a villain comes. Snake.
This predatory reptile will help reveal the secret as it stalks the young basilisk.
That is how it runs.
The basilisk is called the...
If you actually see, there's a lot of physics on this.
Because it can walk.
There's a lot of physics on this. If you think about it. First thing, see. If you see, it can't run slow. It runs pretty fast. One. Second thing, did you see the tail? The tail is acting like a counterweight. The legs are the hinge. The body is on the front. The tail is at the back. If the tail was not there, the lizard will fall into the water. So it's actually like a seesaw. The tail is being actually used as a counterweight to balance, to keep the, the lizard straight. And it is using both the legs like a hind legs. It is doing up and down. Like, that's weird, I know. And the legs are webbed feet so that you can have more contact surface area. So the reason why we call it Jesus lizard is because there's a legend, right? Jesus has walked on the water. So this thing is walking on the water, so they called it Jesus lizard. So I have no idea. That is a name.
Well, really,
but it is running interestingly. It runs pretty fast, see.
Its hind legs, and the tail becomes a counterweight.
There. Did you see how fast it ran? It actually runs pretty fast.
You can't know what the snake is thinking. Did it really
This guy wants to think about the snake. Okay. And this thing, remember last time I was talking about viscosity rings. This is the rings by a volcano. I showed you with a box. This is the nature releasing rings. So, yep. It's a non-Newtonian fluid. We don't study that. Clear with this? Take a break. Come back by 7:05. We'll continue from here. I'm sure people are happy seeing the lizard. Now you have more respect for lizards. Chalo, any doubts so far? Anything not clear? Please ask. Clear? Chalo, back by 7:05. Chalo, let's start everyone. Comes on. So great. So we kept on talking surface tension, surface acts like a membrane and stuff, but what is the surface exactly? So surface is nothing but a thickness of 15 molecular diameters. So basically that's your sphere of influence. At the interface of the mediums. So if you take a liquid drop, comes on everyone. There is one surface. So there's a liquid and air interface. Now, if you take a soap bubble, you have air inside. This is a soap solution. Outside is also air. So this is one interface and this is one interface. So there are two surfaces. This is a surface, this is a surface. So whenever you say soap film, we'll always have two surfaces. And this thickness here, it has almost, 2 to 3 lakh molecular diameters. So thickness of a soap film. So whenever we talk about this word, soap film or a soap surface, you always have to take two surfaces. There, have a look at this. Clear with this? So because of this tendency, like a trampoline, right, that surface thing, so there'll be some forces involved on this. So let's see how will the forces act. Any doubts on this page? Now, suppose if you take a surface, and if you take an imaginary line, let's call this thing A, B, okay? This is C and D. This is E and F. So each surface will pull this line with a force F. So this force is F, A, B, C, D, perpendicular to the surface. This force will be F, A, B, E, F, perpendicular to the line. So the surface tension, right, acts like a membrane. So the surface tension force think of like this, huh? If you take your, let's say you take your ruled notebook, and if you try to stretch the paper, so on your paper there are different lines, isn't it? If you choose any one line, so this line which is there, isn't this part of the paper pulling it this way? So if you take a paper and try to stretch it, and the left side of the paper is pulling this line this way. Now, how is this force? This surface tension force is parallel to the surface, so that is important, be careful. It's not perpendicular to the surface, it is parallel to the surface and perpendicular to the line which you have chosen. So if you have drawn an imaginary line, the force will be perpendicular to that, right? And it is parallel to the surface. These are the two words. It should be parallel to the surface and perpendicular to the line. Meaning you can even take any surface like this. Suppose if you have a surface like this, right? And if you have chosen a line like this, a curve, doesn't matter. So on this side, the force would be like this. It's perpendicular to this. It's perpendicular to the curve and parallel to the surface. The same force will act on the other side also. Getting it? So each surface is pulling with that same thing there. So this force is proportional to the length of the line. The proportionality constant is given by S. So we get the surface tension is defined as force per unit length. This S is a proportionality constant. S is surface tension, which depends on nature of the liquid and the temperature of the liquid. So this is your first formula or the mathematical thing here. F is equal to S into L. Let me show you some examples how it looks. So surface tension force, see, a trampoline never pushes you outside. A trampoline will exert force along the surface. The resultant pushes you outside. There's a difference. Please have a look at this page. Clear? So let me take some examples. So this is more about the surface tension. Before that, let me take some examples. Suppose if you take, think of like this. If you take your hanky or a kerchief and put it like this, and in the middle, if you keep a rod, this is how the rod looks. The surface actually bends. So if you look at the forces due to this, it will be like this, parallel to the surface, perpendicular, parallel to the surface, perpendicular. The side view looks like this. It's like a curve. So this force is acting like this, and this force is acting like this. This angle is theta, and this angle is theta. So the one who is balancing the weight here is 2F cos theta. That is balancing your weight mg. You're getting the surface tension force is not upwards. The surface tension force is along the surface. Think about it. If you're standing on a trampoline, how does the trampoline pull you? The trampoline becomes like this, and you're standing inside the trampoline. Isn't this trampoline here is pulling this way, and this is pulling this way? The rubber sheet is actually pulling you along the surface. The resultant is pushing you out. The one common mistake people have, उनको लगता है surface tension is pushing you out. Surface tension का resultant is pushing you out. The surface tension force is always parallel to the surface. So if I take one more example, let's say if you have a soap film, remember surface tension is a surface phenomena. So there is one surface here. So this is a surface. So there will be a force F is equal to S into L. There is one more surface at the bottom. There are two surfaces. This is due to the lower surface, that is due to the upper surface. That means, they can ask a question like this. You take a U-shaped frame, and fill this with a soap film. And if you have a block of mass M here, if I draw the FBD of this rod, you will notice there's an mg here. There are two surfaces here. There is one surface at the back, which is S into L, and there is one surface on the front, which is S into L. There is a surface on the back and surface at the back surface. This is the front surface. So basically, it is acting like a membrane. 2SL is equal to mg. How do I show this to you? Where is this? Think of like this. I'll show you how. There is one thing. Think of like this. See, suppose you can why is my screen blur? One second. Yeah. So if you look at this paper here, right? So see, normally this is how the paper is. I hope you're seeing the screen. This is flat. But the moment, if I keep a weight, are you able to see how the surface is becoming? So how is the surface pulling here? The right surface is pulling this way, the left is pulling this way, but the resultant is pushing up, isn't it? Now, when I say the surface is keeping here, this is what I was doing actually. This is the rod. So the rod is inside here, and the weight is pulling down. Can you see now there is one surface on the front, there's one surface at the back. Can you see the side view? There are two surfaces which are balancing the weight. So each surface will give a force of S into L upward. This will give you S into L upward. So there are two SLs. Making sense how the surface is looking? So that is the basic idea of that. But let me show you something.
Then
That
you're
will make things
ignoring the
simpler.
dimensions of the body, right?
Which one?
In this, like, because you're not taking the component of the force, right? So you're ignoring
This case you're talking?
the U frame, yeah.
No. In the U frame, how will the force act? The force will act parallel to the surface and perpendicular to the rod. So both are in the same direction.
Right.
So look at this thing. Huh? This will make things clear for you. Where are you? Music will be a little weird, but I think this one, I guess.
In this short video,
Ah.
we will explain the physical negative water molecular effect. This houses cells are in the side.
Yeah, this one.
However, recall that our soap surface actually consists of 2 layers, so we must multiply by 2.
There. Anyone figures out the music? Anyone knows what music it is? SpongeBob.
Yeah.
Yes. Take it. Now see what he did. He made a rectangular frame. There is a rod which is movable. It can slide on it. Okay. Now see what he did. He kept it inside. He took it out. Now can you see 2 soap films? Why is that rod not moving? Because on the right side there is a soap film. On the left side there is a soap film. Both are pulling with SL to SL. So that rod in the middle is at rest. You're getting the force does not depend on how big is the surface. Force depends on length in contact. Now you tell me, if I pop the bubble on the left side, what should happen? The right side soap film will pull it to the right, so the rod should move. See what happens. So he takes a soap film, it is at rest. He takes a scissor and cuts this. Did you see? Why it is coming down? Mg sine theta. So when you lift it like this, the weight mg sine theta is dragging it down. SL is not sufficient to pull it up, so it is coming down. Now see, if you make it horizontal, it goes back. Comes down, goes back. Making sense? So I'm not making this up. Huh? I was teaching you and all, to lagta ha, sir is making up. It actually happens. So just see that again. The music is also cool. Goes off. Mg sine theta is pulling it down. Fair enough.
Then why doesn't it touch the other side fully?
Why doesn't it touch the? अरे वो बीच में देखो ना rod block कर रहा है actually.
अच्छा okay.
वो frame देखा वो curly thing how he made.
Oh, अच्छा okay.
That is ना देखो touch कर रहा है it is not letting it go. Technically it would love to go and make it 0 actually. So that is one. Can you explain with this?
Today, I'm going to show you a really cool experiment with water and ground black pepper. Start by taking a plate, I like to use a white one like this, and pour on some water. Then take your pepper and sprinkle a bit all over the water, like this. You can see the pepper sits on the surface of the water, and if you dip your fingertip in, nothing really happens. You might get some pepper stuck to your finger, but that's about it. Next, take some washing up liquid and wipe a tiny amount on the end of your finger, like this. Then try dipping your finger into the water again.
Goes off.
As you can see, the pepper seems to magically shoot away from your finger.
What happened? The moment you kept that soap solution, it just flew away. We'll talk about
So
that.
here's what's happening.
The surface tension accelerates.
Stay safe, have fun.
Right, that is one. Let me show you one more. We're going to do a question on this also later on. Look at this thing. He took a frame, you made a soap film. That's a soap film. You took a thread, he placed on top of it. It will be a random shape because there is a film inside also, there's a film outside also, net force is 0. It will make any shape. Now, if you make a hole in the inside, it becomes a circle. That's because the moment you pop the inside bubble, the outside film is pulling out in equal directions. The best shape you can form is a circle. Making sense? The surface tension pulls up the string. So, By now, everyone must, you all believe me now, surface tension actually exists. The belief is the most important thing. The biggest problem I face with this chapter, right? People think like, sir, you are just bluffing. The physics teachers are all making up surface tension. So there, you saw mosquito standing, we saw lizard running, we saw people running. अभी इससे ज़्यादा prove नहीं कर सकते. So
The thing he was using, it was so sharp. That's why it wasn't making a whole lot.
where
In that video where he was taking the rope up and down.
that thing.
Yeah. Why was
No,
that?
no,
not-
that does nothing. If you want to pop a bubble, you should touch with a dry surface.
Acha, okay.
If you put your hand in a soap solution and touch the soap bubble, nothing happens to it because your molecules on the hand and the soap bubble molecules are same. But if you put a dry hand, immediately it pops. So that is one. So let me take a few more examples. Suppose, let's say you keep a disc on a liquid. Right, and if you try to pull, this is what happens. The disc just doesn't come out normally, it pulls the surface with it. The surface liquid level rises actually. Remember, I said it's like a trampoline. Think of like this, your shatka button. If you pull your shatka button, how does the cloth come out? It rises, right? So when you pull the thing, it is just like you're pulling your shatka button. Yeah, surface tension decreases. That explanation, I'll tell you. So the force will actually become like this. So if you take the disc FBD, you'll observe there is this component 2 pi r s cos theta and disc weight mg. So someone has to pull out with F external. So if I take this angle to be theta. So if you put something on a water surface and if you pull it up, the water level actually slightly rises. You can do the same thing with a annular disc also. If you make a disc with inner and outer radius, and if you pull this up, same thing you'll notice, but the shape will be a little different. So there'll be one force on this surface, 2 pi r1 s cos theta, if it makes an angle theta there. This will be another force, length into basically the entire length 2 pi r2 s cos theta. So whenever you put something on a liquid surface and if you try to pull it out, it does actually exert a force. Clear with this? Now, coming back to that soap thing now, what happens here, I'll tell you. When you take this, the pepper particles, the surface tension is pulling equally in all directions. So pepper is at rest. The moment you added soap detergent here, the surface tension decreased. So this side, the forces have decreased. So what happened? This thing went away, right? So it gives you a feeling as if they got repelled. Whereas in reality, they're being attracted more strongly by the outer surface. Clear? And surface tension का value, right? It decreases with temperature. Any idea why? If you increase the temperature, molecules will vibrate more rapidly. Because of that, the molecular interactions will decrease. Yep. That's the reason, Aryan. Decreases with increase in temperature. The reason, molecules vibrate more rapidly and the interactions decrease. Second thing, by adding detergent, surface tension of water decreases. But if you add alcohol, it increases. So what are you doing exactly? You're replacing the water molecules with the surf molecules. So the force between water is greater than force between water and that surf, the detergent. So since the molecular force decreases, the interactions are lighter. But if you add alcohol, surface tension increases. Because the bond between water and alcohol is stronger than water and water. So basically, whenever you add any compound into the substance, you need to see whether the molecular strength is increasing or decreasing. So force between water is less than force between water and alcohol. Clear with this? Great. Let's see some questions. Let's start with an easy one. I hope everyone understood this example, right? The U-shaped stream. This is the front view. This is theta. We have a massless rod. And this is a soap film. Surface tension is S. You took a block here, M, and kept it in equilibrium. This is length L. This is also length L. And gravity is present. Find them in equilibrium. Find time period for small oscillations. If you pull the block by X and leave it, if I dip my finger in alcohol and then touch the paper on the water, they will cling to the finger. Technically, yes. But we really get alcohol to try this. Block is pulled down by X and released. Find time period for small oscillations. Sanitizer. Vidyut found by alcohol. Let's get the question, everyone. There, SHM is back. Did I tell you? This will come and hijack you every time. 2SL sine theta. That theta is the full angle, right, God? Theta is the full angle. तो theta नहीं आएगा. Yep. Get the time period also. That is the main one. And please don't forget there are two surfaces. So always into 2 आएगा. There's one surface on the front, there is one surface at the back which you can't see. So your force will always multiply into 2 whenever there's a soap film involved. Okay, the first part is easy. So if you look at this shape here, it is just geometry there. drop a perpendicular. This will be theta by 2. This is L. So this length will be L sine theta by 2. This is also L sine theta by 2. So the total length of the rod is 2L sine theta by 2. So if you draw the FBD of this block, we have S, the length is 2L sine theta by 2 into 2. Why? There are since two surfaces. And mg. Equilibrium 4SL sine theta by 2 is equal to mg. Find the time period. That's an easy one. Now, if I pull this by x and leave it, find the time period for find the time period for oscillations. Here, oscillations may not be small. Two pi root m by 2 tan theta. Rod will come down linearly if I pull. Yes, matlab you're catching the block and pulling down, na?
No, sir, अगर वो सिर्फ बीच से नीचे आता so that would be in a different
बीच से
way.
मतलब
ऐसे
रॉड है रे वो, मतलब when you stretch the rod ऐसा जाएगा ना?
हाँ सर वही पूछ रही हूँ.
हाँ ऐसा जाएगा. Ignore G. No, why will you ignore G? G is always there. Okay, you wrote something, yeah. Okay. ठीक है, actually, हाँ, you see, you can do one thing. Give me an answer without M. You already know M ka value from here, you can substitute in that. You can give me an answer without M. Because in the, actually, if you see the question, question where M is not given. You have to find M. So answer should come only in terms of L, theta, and all that stuff. So try to give me an answer in terms of without M. You're not wrong, but so M, when you see the options, you would have realized it. How to find the time period? Show you? In SHM, what is step 1? Displaced by X. Step 2, find the restoring forces. Step 3, restoring force is equal to MA. Step 4, compare this with A is equal to minus omega square X. So, this guy is L, this guy is L, this guy is theta. Fair enough. I'll exaggerate the figure of mode. So, I will push this rod by X downward, meaning this length is also X. This will be theta by 2. This would be how much? X tan theta by 2. This is also X. This is theta by 2. So this length also is X tan theta by 2. That means by pulling the rod, you have increased the length of the rod by 2x tan theta by 2. Remember, we're not interested in the initial forces. We are interested in the change in forces. The length in contact with the surface increased by 2x tan theta by 2. Therefore, that additional surface tension force, we are not writing the initial forces. The additional surface tension force will be surface tension, the additional length 2x tan theta by 2 into 2 because there are two surfaces. So 4 Sx tan theta by 2 is equal to mass into acceleration. We always choose acceleration in the direction of x. So we get A is equal to 4s by m tan theta by 2 into x. This is your omega square. So time period is 2 pi root over m by 4s tan theta by 2. But I already know m ka value is how much? 4SL sine theta by 2 by mg. You can substitute that. So just take this guy and substitute and finish it off. You'll get the answer. How much you're getting? L cos theta, okay? Okay. 2 by root over L
तो
cos
G
theta by 2g. G भी आएगा अभी. This one, Ishan?
Yes, sir.
Yeah. Got this, everyone? Easy? Why are we not writing this length extra? Because if you take this length extra, then mg anyway will cancel that, isn't it? What you're interested is only the change in forces. Check it out. Clear? Let's see one more. Next one. We have a parabolic frame. Let's say y is equal to minus x square. So this is your origin. So let's choose y is equal to x square. इतना confusion नहीं करते. Meaning you're choosing y as positive down and x is horizontal like this. Plus and minus really won't matter much. So we have a rod here. There is a soap film here. Surface tension is S. So this is origin. This coordinate is a comma 0 comma a. I should take reverse now. Wait, I'll do one thing. Let me define this properly. Let this be x and let this be y. This point is a comma 0.
So it should be y square equal to x.
Y square is equal to x. So let this write y and x only then. Happy?
Yeah, fine.
Right. So it's a parabolic frame. So initially system is at rest. Gravity is there. First question, find mass of the rod. Second question, find time period for small oscillations. Same thing, instead of a V-shaped frame, I made a parabola now. Third question, a block of mass m is attached to the rod. Matlab, you took a block of mass m and we have a hook. You took this thing and attached to it. You kept the hook coordinate suddenly. Find the maximum distance the rod moves downward. Questions clear, everyone? 3 parts. Initially, system is at rest. Find mass of the rod. If you disturb it, they'll oscillate. Find the time period of oscillations. Third part, you took a mass m with a hook and you kept it on the block rod, and this thing started going down. Find the maximum distance the rod moves. Again, one thing I'll tell you: don't get scared seeing the question. Try to understand. You're still solving loss of motion ka problems. The only new thing you learned is whenever there's a soap film, force is S into L. That's it. That is the only new thing you learned. Other than that, the whole problem is simply NLM and kinematics. When you think that way, you will actually see the connection between chapters. But if you think every chapter is new, you will get overwhelmed. So always think like that. How much do I know? I already know 80%. The 20% is new. Think about it till now in this entire chapter. I taught you only one mathematical formula. F is equal to SL. Bus. I'm playing with that only. Let's get this. Mass of the rod is easy. 4SL root A. Yeah, you just find the length of the rod from geometry and finish it off. Get the time period, everyone. And that C part, those are the important ones. 8 SA by G. Okay, you got a good length. Did you get an A square? I'll do one thing with dimensions का problem आएगा. Let's take y is equal to kx square. Let's say y is equal to ax.
Can be
Okay.
y square.
I wrote wrong, na? ये diamond, this thing is messing up. Wait. 0, comma a था वो. हाँ. Will it be fine? Y is equal to a, तो x is equal to 1 आएगा.
So you can make it x square equal to 4ay.
Let it be ना kx square रख लेते. तो नहीं सोचते.
Answer A is the focus.
It can be. Doesn't matter.
Okay.
You want to make it focus, yeah? कर
Yes,
ले.
so that makes the length of the rod easier.
चलो. It's fine. We're not interested in the mathematical thing anyway. Get the equations. If you got the equations, it's just a max after that. Chalo, try everyone. Get the mass of the rod, everyone. That is easy.
Sir, it should be x is equal to
X is equal to
4a y square.
मुझे भी लग रहा है equation somewhere I'm goofing up.
या फिर मैं गलत.
ऐसे सही है वो आपने जो भी किया.
If I put y is equal to a here, a cancel हो रहा है ना?
हाँ तो एक 0 आया.
नहीं, that is. नहीं, x will come after then.
आया 4 ऑब्जेक्ट.
X will come after.
So I think it should be x square equal to 4ay.
x by equal.
This thing, if I just invert this, didn't I just draw? I just wrote y is equal to minus x square graph, ना? कुछ तो वो कर रहा हूँ मैं.
हाँ.
छोड़ना. Just write y is equal to kx square. Just get me the form. Ignore the mathematics. I'm not that strong in parabola.
4s by g is 5.
हाँ, Adrit.
Then the k will come in the answer.
ठीक है ना, आने
Answer I
देना.
don't know.
You don't know the answer. छोड़ना, ठीक है ना. Let's assume something. What did you guys check? Y is equal to x square or y is equal to that thing? Ignore na. Let's solve. You got the basic concepts, right? Let's see the first part. Let's not worry about that stupid equation. So you just want to find this length. This is 0, 0. This is 0, a. So this coordinate will be x, a. So we know y is equal to kx square. So if you put y is equal to a, so we get x is equal to root a by k. So I know the x ka value. So this is x. This is x. So on the rod, the force will be 2sx. There are two surfaces. S into 2x into 2, and this is the weight of the rod. So 4x is equal to 10. Just check your equations. If you got the equations right, forget about all the variables. So 4s root a by k by g is l. Okay? That is the easy part. Get the time period. K, I wrote it, na? Clear, na, Aryan? S into 2. Arey God, what is surface tension for? Surface tension into length of the rod. Length of the rod is 2x. Clear with the mg part. Don't worry about the equation. Forget about it. Find the time period. You just need to find the length of the rod. Get me the time period for small oscillations. Here, this is the question. Should I help you? 2 pi root 4s by g. I don't know the answer. Let me help you out here. See, what again? Remember, what you're interested is not the actual length of the rod. You're interested in the change in length of the rod. So when the rod is here, let's displace this by y. Okay. Now let's find the relation between them. So when you say y is equal to kx square, try to understand dy will be kx dx. करेंगे? So dx is nothing but dy by kx. So this is the change in x coordinate basically. This x is that initial, whatever is the initial length. So if I call this thing what a, right? So dy is this. So if I pull this down by y,
2kx dx.
yeah, sorry, 2kx dx. So this is that increase in dx. This is that increase in dx. So whenever you pull the rod by dy, the length of the rod increases by 2 dx. Then we are keeping that 2. We have 2 is there. I forgot to write. Okay. So whenever you displace this by dy, so dx would be, you can write that x ka value. Remember this x is the length of this thing. How much is this? This was a initially. So dx is dy by 2k. Technically this x is x plus dy, that the vertical had a plus dy, but we can ignore this. This x was actually length of the rod. How much was that? Root a by k. This is actually root a by k plus the dx. We ignore this. Clear with this? So that means whenever you pull the rod by dy, the length of the rod will increase by 2 dx. So the restoring force will be surface tension into 2 times dx into 2, because there are two surfaces, is equal to minus mass into acceleration. So this is 4s, and that will be dy by 2 root ak is equal to minus ma. I will write this as capital M because you're already using small a. So acceleration is 4s by m, 2s by m root ak into dy. This is your omega square. The time period is 2 pi root over mass of the rod into A into K by 2s. Mass of the rod we already know. You can substitute that and you can simplify the answer. Mass of the rod is how much? 4s by G root A by K.
Sir, can you explain the integration part again?
Integration. I didn't integrate, right?
Sir,
Differentiation.
the same thing, whatever.
No, I just
It
see.
doesn't
Let's
clear
try
up
to
then.
understand. Like whenever I pull this by dy, I'm interested to see how much this horizontal length is changing. No.
I got that.
So we got dx is equal to dy by 2kx. So what is this? This is a change in x for a given dy from a given position x.
Mm-hmm.
So what is that x? That was the initial x, no? This x was the initial x constant, isn't it?
Okay.
That was x was this length, na, initially.
So that's y
But
now.
sorry, x was this length, na, initially.
Hmm.
So that is actually supposed to be the new x, but that will be how much? X plus 2 dx, no? But dx is so small, you can neglect it. So you can write the
Okay.
previous value only.
Okay.
Make sense?
Makes sense.
Is everyone getting what we did there? This x was that initial x value. Please have a look at this. Maybe I should have kept the frame this way, na? Life would have been easy. Okay. But everyone got the steps. What you're always trying to find is the change in length. If you pull the rod by dy, I'm interested in finding this is that additional length of the rods. Anyways, that is one. Make sure to check it out again. Let's see one more homework question. Try this and come. Next class we'll be discussing this. We have a semicircular frame. Radius r. And there's a soap film inside. So what will happen to the soap film? Every point is going to pull like this. Remember, the force is perpendicular to the surface. You just can't add s into pi r. Find force on the frame. Second thing, let's say I made a weird shape like this. This point is 0, 0. This guy is a, 0. This guy is a, b. And inside there is a soap film. And this curved surface is some equation. I don't know what is the equation. Y is equal to f of x. Some random equation. This is a soap film. But something weird happened. The surface tension is not constant. The surface tension Sxy, it changes with both of them, is given by S naught by AB into x square plus y square. Means the more you travel horizontally, the more you travel on this thing, the surface tension will change. Find force on the curved surface. I forgot the C part also, no? So that also tries the homework and come.
The A part, will there be two surfaces?
A part, yes, there will be two surfaces, no? That's where I wrote 2, no, into.
No, sir, in the
The gravity है क्या? हो जाए sorry next homework question.
इस केस में नहीं I just wanted to find the surface tension force.
हाँ okay ठीक है.
sir, दो film.
हाँ, 2 films will be here. See, if the moment is a soap film, there are always two surfaces. Yeah, C part, try it as a homework. We will discuss this also. You can try this as a homework. If you put a mass m on this, what's the maximum distance it travels? And these two. I just wanted to find the force on that red color curved surface. But in this case, now surface tension value is also changing, so be careful. There. So try these 3 questions, 3 parts, and Friday when we catch up, first thing in the class, we'll discuss this. Right, and then we'll do few more problems on this. Then we'll go to surface energy, and then we will go for contact angle and capillary action. Like I said, the chapter is really not that big. Mostly we should wrap up in another 1.5 class, and then we'll go for elasticity. All these are small chapters. Together, it is called properties of matter. Is the homework question clear, everyone? So that's the 3B part. The surface tension is variable. Okay, so with that, we'll wrap up for the day. So do try them. That parabola thing, check it out again. I know it was a little confusing. I should have get the equation properly. I goofed up. But yeah, you guys are experts in parabola. Should be able to handle it. So let's get this thing. Okay. Any doubts? Anything stay back and ask? Also free to leave. Any doubts in today's class? You can ask first. Any other doubts? You can WhatsApp me your doubts. Or else you're free to leave. I'll see you on Friday at 5:30 at the same time. So take care. Stay safe.
Bye, sir. Thank you.
Bye.